these functions. One is push, another is pop, and then empty. These three functions are associated with both the data structures. In stack, we have only one end to put or retrieve data, and in queue we have two ends for one for adding element or putting elements in the queue, adding elements, and another end is to delete element, right? In stack, this end is called top of the stack, and we imagine the stack in vertical position like this, vertical position, and we always add element which is pointing by top of stack. If it is 2, then that means 0, 1, 2. These two elements are filled with data. This element, this location is free for adding data, and this is called top of the stack. Normally it is denoted by top of the stack is this, but please keep it in mind, this is not actually a pointer. Okay, this is not actually a pointer, although it is mentioned in lot many times. TOS as a pointer, but it's not actually a pointer. It's only the location which is denoted by top of stack, right? Similarly, in case of queue, we have two ends. One we can sometimes we call it top, or also known as front. Okay, top and bottom. And actually top, if I say top, we can say rear, and bottom is means front. These two terms are used, and we imagine the queue as a horizontal architecture or structure. And here this point, this is 0, this is 1, 2, 3, that way it will go on, and top is somewhere here. If I say top equals to 3, that means we have this place free to add data, and that's why there will be elements here 6, 7, and 8, and this end is called front. Front is equals to 0. In case of queue, if we want to delete an element, then we will take into account the front, and if we want to add element, we will take into account the top, or also known as rear. R is rear. Okay, rear, right? So these two operations are carried out in these two different locations, and that makes stack and queue different. And based on the application that we have in our hand, either we can use a stack data structure or a queue data structure. And moreover, we implement both stack and queue as ADT, abstract data type, so that user of these two data structures can directly use the function push without knowing anything about its internal implementation. It means that if I say push 7, then we will find it somewhere here, and immediately top of stack will move to this. The user of this function need not have to worry about that, how it actually works. So that is why it is called an ADT. Similarly, based on the application that we have or the problem that we want to solve, we can make use of the queue data structure as well. So this is the basic idea or basic concept about stack and queue. So it is very important to understand where can we use this stack and where can we use this queue. Let us take a small example. You might be aware of subprograms. You might be aware of the concept of subprogram. Concept of subprogram, you might have studied in your C programming that function calls. If you consider function calls in a program, when we call a function, say one function we have function A, then another function we have function B, another function we have function C, and this is the starting of our main program, our main function, and execution will start from here and it will go on doing this. And let us suppose here we have function A defined somewhere here, B defined here, and C defined here. And let us suppose that this address is 1, this address is 2, this address is 3, because each of the statement in the program has some specific address assigned. Now when this function is called, let us suppose that this statement is 2, this statement is 3 or 2a, this is another statement which is 3, this is 3a, like this. So when this statement is executed, when we execute this statement, actually this program jumps here, control jumps here, and after that it comes back to 2, right? Similarly here, when we call this function, it jumps to this one, and when it ends, it comes back to this. Again, when it goes here and it comes back to this point, let us suppose that this is 4. So in that type of, this is the function of the compiler, or also we can say this is the function of the system software. And what it does, when this type of function call arises, then it makes use of a stack. Why? Because suppose this is a stack maintained, then this stack basically it keeps track. Suppose one is executing, when it goes to this function, then it puts the next address. It comes from the program counter, this address here, this address here. Now this is the top of stack. If I consider this is a stack, then this is top of stack, and this is the first location. And when it will come back, actually how it comes to know that it should execute from this statement. So in that case, the compiler will execute one pop statement on the stack, pop. Whatever the pop retrieves, suppose that x is 2, that means it understands the control should start from the statement number 2, right? Similarly, we can have some function calls here. So what it will do, it will go here and then it will put where to sell it. This is say 8, statement number 8. When it goes here and when it will come back, it should come back to 8. So this 8 will be pushed here. When it will come back, it will pop. It will understand that it should start from statement number 8. This is the statement 8. So in short, what we can conclude that the function calls in any compiler, function calls in any compiler can make use of stack data structure. This is one very important or very well-known application where we make use of stack data structure. On the other hand, suppose I have a printer and I want to write a printer driver. Normally printer is always shared among different users. So that's why what it does, it maintains a queue of operations. In this we have two parts. One, we have two locations. One where element will be deleted, this is known as front, right? And another point where we will add elements, right? So suppose this is user 1, he wants to print one document. This is user 2, wants to print another document. This is user 3, wants to print another document. What you will do, based on the arrival of the request from different users, suppose that the request from u2 has arrived first, so it will put u2 here, second u3, and third u2. This becomes a queue, and when the printer will take the task to accomplish, or it will take the content to be printed, what it will do, it will first remove the content from the front, and that will be completed. So u2, document submitted by u2 will be printed first, then after completion of this one it will take this, so it will remove this one, front will move, then again front will move. So it will perform the operation based on their appearance. The task coming first is served first, right? So this is one example. Apart from that, in operating systems there are called scheduling algorithms. They also make use of queue data structure to provide services to multiple processes, right? So these are few examples of application of stack and queue. Okay, so if I say 3 plus 4 minus 2, what will be the result? 5, right? So how do you do that? Did you do 3 plus 4 first, then 7 minus 2, or what we can do, 3 plus 4 minus 2, this is also 3 plus 2. Okay, it both the way correct? Is both the way correct?
Yes, sir.
Yes, both the way correct. Now suppose that 3 multiplied by 4 plus 2, then what will be the result? 14. Why not 3 multiplied by 6? Why not 18?
Sir, according to
yes, that's what I wanted to know.
we perform the multiplication at
Yes,
first.
this one, because we have to follow certain precedence rules, right? Precedence rules means if it is the statement, actually this is this one, this is this one. This is not if I write explicitly. If I want to perform this operation, then I have to tell explicitly. And what is this called? Parenthesis. Why do we use parenthesis? To state precedence. Precedence of what? Precedence of, in any expression, these are called operands. Operands, right? And this is called operator. And specifically this one is called binary operator. Binary operator. Why it is called binary operator? Because it takes two operands. And binary operator, every operator has precedence, and that is based on certain formula. It's about mass formula. And in order to express our preferences on the precedence, what we do, we make use of parentheses, right? If I write this expression, what we do, we always write down the operator between the two operands. If I write down this way, this is called an infix notation for expressing expressions or for representing expressions. In case of infix notations, when we express any mathematical operations, or when we represent any mathematical expressions using infix notation, then the parenthesis plays a vital role in representing the meaning and precedence of operators. What does this mean? It means that if we have, say, any expression A multiplied by B plus C minus D, if I do not use any parenthesis, then what will happen? It will use the default method of evaluating this expression based on some precedence. But however, if I want to do like this, then you must have to use parenthesis, and this parenthesis will ensure the execution of the precedence rule in a predefined method or predefined approach. Here predefined approach is, I want to perform this operation B plus C first, then I want to perform this operation minus, then only I want to perform the operation multiplication. Otherwise it would be done A multiplied by B, and it will read from left to right, and then this part will be evaluated, then this part will be evaluated. So in order to avoid such kind of default process of evaluating it, what we do, we make use of the parenthesis plus C minus D, and then I will tell that this is the first one to be evaluated, this is the second one to be evaluated, this is the third one to be evaluated, like this, like that, this one. Okay, so if I do this one, basically in computer programming, when we implement using a program, when I use this expression using a program, programmers think that this is not a right way of expressing any mathematical formula or mathematical expression. This is not the right way. Why it is not right way? Because we have unnecessary these things, this parenthesis. Apart from that, we also have to take care of operator precedence every time while executing that statement. Okay, any kind of statement like 3 multiplied by 4 plus 2, every time we have to take care of this parenthesis as well as their operator precedence, right? So that is why the programmer thinks, that developer of programming language, they think that this is not the right way. That means infix expressions are not the right way of expressing or presenting any mathematical statement or mathematical expressions in a program. So that's why they derive two different methods. The first one, they said that if I wanted to evaluate the expression 3 plus 4, this is infix, let us not represent in this way. Let us represent, first we will write 3 and 4, then we will put the operator here. And it implies that unlike infix expression, unlike infix where we put the operator between the operands, unlike infix, in this one let us put this operator at the end. Let us put the operator to be placed at the after the two operands, right? So this is one notation which can be used in place of infix, and this expression is called postfix expression. Postfix means post, after. Operators are placed after the operands. And another format they have suggested, that let us put the operator before both the operands. We are talking about binary operation. If it is binary, then definitely there will be two operands and one operator. And that's why here what we are doing, we are putting the operator before the operands, right? One way of expressing it, to put the operator after the operands, a plus, ab plus. And second choice is to put the operator at the beginning, before the two operands, right? If I do this, then this is called a prefix notation, right? So what they have suggested, this infix notation is not good because of use of parenthesis. And second one is to keep track. We have to keep track of the operator precedence. That is why they have given two alternatives for this infix expression to be used in any programming language. That is, one is called prefix notation, where we put the operator before two operands, and another is postfixed expression, where we put the operator after the two operands, right? If we use any one of the expressions, then we can eliminate the need of the parenthesis and the precedence rules to be remembered. These are the main benefits of converting an infix expression either into prefix or into postfix. Normally, most of the programming languages like C, C++, Java, they make use of the postfix expression while compiling your code with respect to any mathematical expression, right? And this mathematical expression evaluation is very fundamental issue in programming language. That's why while evaluating this type of expressions, it says that the existing infix expressions are not suitable for evaluating expressions in programming. That's why they have given two different methods, either prefix or postfix. But however, when user will write the program, the programmer will write the program, they will give this one in this infix notation, and we cannot, because we cannot expect that all the programmers are aware of infix and a prefix and postfix notation. So the programmer will give this expression in infix, and it is the responsibility of the compiler to convert automatically into either postfix or into prefix, depending upon the type of compiler we use. And mostly they convert an infix expression into postfix expression before the code get executed, and this is done in the compilation phase. So now here, when we convert any infix, we will talk about conversion of infix into postfix expressions. In this case, when we do this program, then we make use of the stack data structure. It is a very, very important and prominent application where the stack data structure fits. Okay, so what we need to do, we need to write a program to convert an infix expression into postfix expression. This is our problem. Write a program to convert an infix expression into postfix expression. For example, if our expression is A multiplied by B divided by C plus D, it is in infix, and I want to perform this operation as B divided by C, then multiplication, finally I want to do this. So what will be the, say, A multiplied by B divided by C. I want to evaluate this one first, after that I want to evaluate this, plus D, I want to evaluate this at the end. So this is the first one to be evaluated, this is second one to be evaluated, this is third one to be evaluated, and this is infix expression, infix. And if I convert it to postfix, then it will look like BC, this is the innermost, so I will write BC, I will put this at the end, this is one block, then after that this star will come here, and A will be at this place, then D will come here, and plus will go here. And moreover, in case of this is actually the postfix in its basic form, but in postfix we do not have these brackets, so it will be A, B, C, this, division, then multiplication, D, and plus. So this will be the expression of postfix expression for the given infix expression.